Welcome to the Math Record. Today I'll be covering the second part of the ICTM Regional 2020 Division AA Precalculus, which I'll be answering questions 11 and 15. Okay, let's begin with 11. The point P, 9, 6 square root 3 is plotted on the standard xy plane. Just the x and y axes are rotated 30 degrees counterclockwise, but leaves all points, including P, in their original position. Determine the coordinates of P relative to the new axes. So, what we could the general way of how you could kind of solve this is that we could have a coordinate plane, and then we have our point, right? And then we rotate our y-axis, rotate our x-axis by 30 degrees counterclockwise. Looks kind of bad. So this would be 30 degrees, this would be 30 degrees, right? What we could do is that you can find the distance between this point and this line, which give us our y value, and we can find the distance between this point and this line, which give us our x value. So that's one way to do it, but that's kind of long because we need to find the equation of our two lines, this line and this line, and then we need to find our distance. So that seems kind of tedious. So instead of moving the axes, we can move the point, which we would be using our calculator a bunch. So what we're gonna do is put a point, and then we could just draw a line from the origin to that point. So what we do is that if the axes are moving 30 degrees counterclockwise, then what you want to do is that when you have a axes that stay the same, then you have to move the point relative to the axes for that 30 degrees counterclockwise. So basically, instead of going 30 degrees counterclockwise, you're going 30 degrees clockwise because it gets closer to the origin. So it looks something like this. So our line will rotate 30 degrees clockwise this way. And it'll be the same length, right? Because it's just a line that's rotated. So it just went 30 degrees down. So I'll just label this as 30 degrees. Now, where I'm going to make some right triangles using these points. Then here. Okay. So we know some of these values already. The x value here is 9. And the y value here is 6 squared root 3. To get our hypotenuse, x squared plus y squared. So 9 squared plus 6 squared root 3 squared, which is, and then take the square root, which is square root 189. So that's our hypotenuse. Since this is rotated in the same length, this line is also square root 189. So now we just need to find our x and y values, which basically we just use simple trigonometry. So it's just called this angle theta. So to get theta, we need to find this entire angle subtracted by the 30. So the entire angle is just an inverse tangent of 6 square root 3 over 9, and then we minus the 30 to get our theta. And then we can have our y value, which is equal to the hypotenuse, which is square root 189, multiplied by sine of theta, and our x value, which is b square root 189, multiplied by cosine of theta, right? That's just basic trigonometry. So we could just do this on our calculator, and we're not going to do any rounding because that's going to be imprecise. So inverse tangent of 6 square root 3 divided by 9, then minus 30, and then do the sine of that angle multiplied by square root 189. And our y value should come out as 4.5. And then we have square root 189 times cosine of that angle. And you should get something like 12.1, 12.99038, etc., which makes like really, really imprecise. So we're not going to use this because it's going to be some kind of radical in there. So instead, what we could do is that since it's a right triangle, we could just use the Pythagorean theorem. So the hypotenuse squared, so square root 189 squared, is equal to x squared plus y squared plus 4.5 squared. So then we have 189 minus 4.5 squared. Number, make it a fraction. So 675 divided by 4 equals x squared. So that means our x is equal to divide by 225. And we're left with 3. So this is going to be 15 square root 3 over 2. So our point is 15 square root 3 over 2, comma, 4.5 is just 9 over 2. And that is our answer for number 9. Okay, I mean, not number 9, number 11, sorry. And then number 15. The common points of two polar graphs r equals 3 and r equals 6 cosine of 2 theta from 0 to 2 pi determine a polygon. Determine the numeric area of this polygon. So to solve this question, you need to understand how polar graphs work. So let's just draw a picture to see what's happening. So we have some circles. Looks fine. And then we have something like this. Make it a bit smaller. So it's not really a precise graph. We're just drawing a general idea of how it's supposed to look. Okay. So our first equation is r equals 3. So it's going to be a circle of radius 3. So it's going to look something like, something like this. And let's make it a little bit bigger. Okay. So something like that. So let's actually start labeling some stuff first. So let's say our first inner circle is radius 2. And this circle is radius 4, and this circle is radius 6. And this circle is radius 3 from our equation, but we don't really need to label that because we know it's 3. And then we have another equation, which is the radius is equal to 6 times cosine of 2 theta. So this is going to be a rose, and how it kind of looks is like, this kind of looks something like this, like some kind of rose. So how do I know it's 4 petals? Well, it's if it's an even inside, and it is even because it's 2, then the equation is 2 times the even side. So 2 times 2 is 4. So there's 4 petals. And how it goes up to, it's 6. So it goes 6 here, 6 here, 6 here, and 6 here. And it should be the petals should be like evenly uniform and like kind of symmetric. So basically, how it's supposed to look. I'm really bad at drawing this, but how it should be drawn is something like this, and then go from here, go around, then from here, go around, like that. So we have something like this. And then we need to find our common points, which is the first point, the second, the third, the fourth, the fifth, sixth, seventh, and the eighth. So there's 8 points. That means there's 8 sides. So this is going to be an octagon. So something like this. Actually, let's use a different color so we can see what's happening. So something like that. So I have really bad drawing skills, but basically this graph and the circle are both symmetric. So if we cut it right here, cut it right here, cut it right here, right, cut it in like a 45 degrees, and then from like in that diagonal, and then cut it from this diagonal, they should all be symmetric at each point. So, well, not the graph itself. Well, yes, the graph itself, but the I'm saying for the two polar graphs, they should be symmetric. So overall, the points of intersection that makes the shape should also be symmetric, logically speaking. So we have this octagon that looks something like this. So I'm going to delete this, and because now seeing how this looks, right? So memorize. Well, you don't have to memorize it because you just look at the video. But basically, we're going to have something like um, an octagon looks something like this, and then it's got to be really small, and then we have like a really long side, then we have this goes back down, and I'm trying to draw as precise as possible so it doesn't look too bad. So it's something like this, right, where basically you could split it up in its halfway. So split it up right here, and we could split it up right here. And I said before that since both graphs are symmetric, because it's just a circle and a rose that's symmetric, basically that the shape that they create should be symmetric. So like that. So if we cut it up like this, that means this area should be equal to this area, should be equal to this area, and should be equal to this area. So what we'll do is just find the area of one of them instead of the entire octagon, because that's taking a lot of work. We'll find the area of this and multiply it by 4. So to get the area of this, how do we do that? Well, we need to find these 2 points. But as usual, since it's symmetric, basically this line is equal to this line. And all we have to do is basically find this point and kind of rotate the points around to get this point. So what we could do, basically, let's move this shape a little bit over. So we could do some math. So let's go back to white. So we'll draw a line from here to here. And that's a right triangle because it's perpendicular. So how do we get our point right here, this point? Well, basically, we know that the radius is equal to 3 and the radius is equal to 6 cosine of 2 theta. So we set it equal to each other because we're looking for, because all these 8 points are points of intersection. So then we have 1/2 is equal to cosine of 2 theta. So for cosine to equal a half, it has to be 60 degrees. Well, the lowest, it has to be 60 degrees. That means 2 theta has to be 60 degrees, so theta equals 30 degrees. So from there, that means this angle is 30 degrees because that's the smallest. And what is our radius? Well, radius is equal to 3. So, right, because if you plug in 30 degrees in both the equations, it's just radius is 3, and then cosine of 60 is going to be 1/2, and 1/2 times 6 is 3. So this is radius 3. So now we could find the angle measurements. So this is the 30 degrees, so that means this is a 60. So this is the 30, 60, 90 triangle. So opposite of the 30 is half the hypotenuse, so this is 3 over 2. And opposite of the 60 is multiplied by square root 3 over 2. So we had 3 squared 3 over 2 and 3 over 2. So to get this coordinate, as I said before, that's symmetric. So this side length is equal to this side length, and this side length is equal to this side length. So this is going to be 3 over 2, and this is 3 square root 3 over 2. So that basically, since this is 3 squared 3 over 2 and this is 3 squared 3 over 2, the area of this, if it's a square, would be 3 squared 3 over 2 times 3 squared 3 over 2, which is 927 over 4. So we have that square minus this triangle that they make. So how do we get this triangle? Well, we need to find the side length. Since it's symmetric, we just need to find one of them. So it'll be 3 squared 3 over 2, which is the entire side length, minus the part right here, which is minus 3 over 2. So the entire, so then we could square that to get our area. So we have 3 square root 3 minus 3 over 2 squared, and then multiply by half to get our area of our triangle. So 3 squared 3 squared, which is 27, plus negative 3 squared, which is 9. So 27 plus 9 is 36. And then 36 minus 3 times 3 is 9, times 2 is 18, so minus 18 squared 3. And then 2 squared is 4. And then we multiply by half. So then we could just divide by 2 to get rid of this half. So we get 18 minus 9 square root 3 over 4. So that's the area of this triangle. So to get the area of this entire blue section is just 27 over 4 minus 18 minus 9 square root 3 over 4. So 27 minus 18 is 9. And minus a negative minus a negative 9 square root 3 is positive 9 square root 3. And then we divide by 4. So that's the area of this section. So the area of the entire thing, you multiply by 4, and that should come up as 9 plus 9 square root 3. And that should be the precise area of this octagon. So since they ask it for to the nearest thousands, just plug this in your calculator, and it should come out as 24.588. And that is your answer for number 15. Well, thanks for watching, and I'll see you at the next math record.